The next force that we'll talk about is pressure. And pressure is defined as a force that exists over some unit area, some area. And pressure varies with time. At a given location, you can see pressure change with time just watching a barometer, but also it changes with distance. Moving from one place to another, you'll see changes in pressure. So we define the pressure gradient as some change in pressure over a given distance. And I think you've calculated that already in a lab. So you know what pressure gradient is. Remember that pressure gradient is a vector, and a vector has magnitude and direction. So we can break our pressure gradient into Cartesian coordinates. We can also talk about it in actual coordinates. But we're going to stick with Cartesian coordinates here. We're going to use our standard vector notation, which is the del operator. And here we have del P, which is the pressure gradient, is the change in pressure in the x and pressure change in the y, at least for the horizontal. But also you know that pressure changes vertically. As you go up through the atmosphere, pressure decreases. And that is a pressure gradient, actually. So if pressure changes vertically, and we have in our Cartesian coordinates z is our vertical axis, we can say that the vertical pressure gradient is dp dz, and the k is just a unit vector. You've seen this before. This is what we've used in the hydrostatic equation. So here's our three-dimensional pressure gradient. You've got delta P delta x and delta P delta y, which is your horizontal pressure gradient, and then delta P delta z, which is your vertical. Add those three together and you have a three-dimensional pressure gradient. So what we need to do now is figure out the force. And to figure out the force that's caused by pressure, you know that pressure is a force per unit area. So if you multiply pressure times area, you'll get a force. So the area that we're looking at is a hypothetical area. It's a cross-section of the atmosphere. And we're going to define that as delta y, delta z. So delta z is going up, delta y is going north, and it's infinitesimally thin, so it's a surface area, and a force is acting on that area. Force acting on that area is pressure. So from our equation, pressure times area is equal to force. The area we defined is delta z times delta y. Multiply that by pressure, and that'll give us the force in the x direction. Now, as you move in the x direction, pressure is going to change. You're going to have a change in pressure, delta P, as you move towards the east. So our pressure gradient is the change in pressure, delta P, over that distance, delta x. So if you want to figure out what the pressure will be at some distance, delta x, towards the east, then you take your pressure gradient, delta P, delta x, multiply how far you moved in the x direction, that would be delta x, and then add that to the pressure at which point you started, where you started from. So that tells you that P plus delta P delta x times delta x will give you your new pressure at some given distance to the east. So if we take our original pressure and subtract the new pressure value, then we'll get the pressure difference. And that's what your delta P delta x times delta x is. But there's a minus sign out in front. So this is the pressure difference between those 2 points or those 2 locations. Now the force is, we came up with an expression for the force. We said force was the pressure times the area. We came up with the change in pressure, delta P, and if we multiply that by the area, then that'll give us a force. So we're looking at delta P divided by delta x times delta x, how much pressure has changed. That gives us how much pressure has changed, multiplied by delta y and delta z will give you the force. We're going to rearrange this equation a little bit. We're going to pull out that delta x, and that leaves us with just the delta p delta x in the parentheses, and I forgot the minus sign there. And on the outside we've got delta x, delta y, delta z. That's a length and a width and a height. When you multiply length with width times height, that gives you volume. So now we have an expression for the horizontal pressure gradient force. It's the change in pressure over some distance, delta x, times the volume v. And don't forget that minus sign. That minus sign is really important on in front of that delta p delta x. So this is our pressure gradient force in the x direction. You can also do it for the y direction the same way and also the z direction in the same way, and you come up with the same relationship, except that the pressure gradient will now be, the change in pressure will be in the y direction and also in the z direction. So if we combine that together, remember that we can use the del operator on p to tell us the change in pressure in the x, the change in pressure in the y, and the change in pressure in the z. Multiply it by v. So that gives you a nice little shorthand instead of having to write all those nasty little partial derivatives. So what does that mean? We've gone through the math and that was so much fun. Now let's look at what this means. Here we have a pressure gradient in this map. You see a low that's just over, I think, Nova Scotia, or is that New Brunswick? And you can see that pressure changes as you move towards New York State on this map. So there's a pretty strong pressure gradient. So which way does the pressure gradient point? Does pressure gradient point from low to high or high to low? Well, if you remember from the last lab, or a couple labs ago, we said that gradients are vectors and they always point towards higher values. So that's what we have here. The pressure gradient points from the low to the high. That's the gradient. But remember that our equation for force had a minus sign in front of it. And that minus sign is really important because that tells us that the force acts in the opposite direction of the gradient. So our pressure gradient force goes from high to low. And this is something you learned back in 110. Remember that you came up with the idea or the concept that wind blows from high to low. That's your pressure gradient force driving the wind. But the gradient, by definition, gradients always point from lower values to higher values. Next, we'll be talking about Coriolis force.